Hello, everyone. Welcome to LunchBytes. We are back. We're so excited for the last episode of the season. Hi, I'm Steph, and we're just really quickly going to walk you through our code of conduct before we get started. So as always, we're just going to ask you to be aware of others, be welcoming and respectful, be understanding of differences, be patient and friendly, be open to all questions and viewpoints, especially in the chat, and be kind and considerate of others. So if you'd like more information about our code of conduct, you can go to aka.ms/events.co. And then moving on, today's show is also available with live captions on the Learn TV YouTube page. And so you can check those out as you can view this also on demand. So what is LunchBytes? We are a show that appears every other week or every 2 weeks. And so Annika, myself, and Tig, and Asta will also be joined by technical experts from across the UK to answer your top questions about Azure that you've been submitting. So thank you so much for submitting your questions. And if you have any other suggestions for LunchBytes and topics you'd like to hear, please let us know. Just a heads up that we'll be taking questions throughout the event, but we'll be answering them towards the end. So if you have any questions for our speaker or any of us, we will get to those as soon as we can or answer them on the spot in the chat. So like I said, hi, I'm Steph. I am one of the audience developer, the developer audience go-to-market managers here in the UK. And here are my co-hosts. Annika is unable to be on camera. There you are.
Hi everyone, my name is Annika. I'm the Cloud Solution Area Specialist at Microsoft under App Innovation, and I'm working with Steph and Ty today to host you guys. I have some technical difficulties, so can't be visible, but handing over to Ty.
And Tig is also having technical difficulties. So we will, he's one of our cloud solution architects, and where he'll be chatting with Chris throughout the presentation, but I'll go ahead and jump on in and we'll present Chris Reddington, who has also hosted the show previously this year, and I'm really excited to bring him on, a good friend. So hi, Chris.
Hello. Thank you for having me. It's a pleasure to be back. Good to see it all still going. Good to see the thriving content as well. While I was backstage, was just taking a look at all the sessions that have been happening. So thanks for having me.
We're excited. Just a heads up for everyone, this is going to be our last session for this year, but we're going to be starting LunchBytes Season 2 next year. And so we'll be providing all the dates and content for that and have those ready within our YouTube channel, and more surprises about where we're going to be hosting the LunchBytes site. So very excited. Over to you, Chris. Let's go ahead and get this kicked off.
Super. Thank you very much. So, hey folks, just in case you didn't tune into LunchBytes in the very beginning where I helped kick it off here, Chris Reddington. I've changed role and changed company since then, I suppose. So was a cloud solution architect at Microsoft. Now I'm actually at GitHub. I've been here for 5 or 6 months now, and lead our enterprise advocacy teams across Asia, across Europe. So work with customers really, whether it's large enterprises, whether it's kind of small startups, helping them love GitHub, helping them understand how they can use GitHub in their day-to-day work. So what we're going to be talking about today is end-to-end inner sourcing and secure development. So hopefully some tips and tricks along the way, how you can go and use GitHub for your daily development. That's what we're going to be covering. So Steph, if we can bring up my screen share here, that would be super and we can get going. So just in case, and I'll keep an eye on the kind of comments coming in as well, folks. So if you've got questions along the way, I'll do my best to address those as we go, but would love to see some interaction because there'll be some questions along the way too. So do get responding. So to kick off then, just as a bit of context setting here in terms of GitHub, the platform, etc. GitHub, I guess, is really well known from the open source perspective as the home of open source. When you think of projects like Kubernetes, React, Vue, Hugo, Visual Studio Code, many, many others, they are hosted, ran, and maintained on GitHub. So GitHub as a platform has over 94 million developers. We actually updated these stats just, I think, about a month ago now, when we had our GitHub Universe event, our annual big company conference with loads of announcements. So over 94 million developers, 4 million organizations, and that translates into 3.5 billion contributions per year. So the insights that I'll be talking about with you today are really based upon what we learn from the community, what we learn from whether it's enterprises, startups, or our open source community as well. So what we're going to be covering here is this idea of inner source. But before we really talk about that, something that's really important to us here at GitHub is thinking about developer experience. So if you think about life as a developer, it's actually kind of hard because we've got to learn the latest programming languages. We've got to understand those concepts, those principles from a computer science perspective, how to kind of go and test, how to optimize, etc. And over time, the role has kind of evolved. Cloud has come along. Now we've got to really understand how to run cloud services and integrate with platform as a service options as well. In most cases, then we start actually operating those environments. We start having to run them. So a site reliability engineering perspective, the role is really growing over time. And for us at GitHub, we see that as making the role, it's really getting complex. It's getting harder to do the day-to-day. And we know this as a time where the industry is really looking for developers to continue growing in different businesses and to really help organizations go and digitally transform. So something that we care about as GitHub a lot is how we can help that developer experience. How not only can we make you more productive, but how can we make you happy while you do that? How can we make that experience really seamless and just a joy to do development and engineering practices? So keep that in mind as we talk through some of the concepts, some of the ideas here as we go through this session. But the reason I bring this up is developer experience is not just on companies like Microsoft or GitHub or others to really think about. If you're an engineering lead, it's something that you should also be considering as well for your team. So how do you make sure that you are bringing the best developer experience that you can for your team? Because if we think about it, a lot of organizations today work in silos. So the analogy I always like to give is, let's think of a big enterprise where there's many, many different teams. Maybe they're building some kind of retail application, let's say. You might have a team which focuses on the shopping cart. You might have a team which focuses on the catalog service, the user profiles. Maybe there's some kind of back-end team, etc., etc. And typically what you see happen in these organizations is this idea of Conway's law, that you're going to build software based upon the structure of the organization. And inevitably what happens over time is those silos emerge. And what silos mean is they mean friction. So one team could be working with another team more effectively, but what I've typically seen from the enterprise space is it becomes very ticket-based. It becomes very kind of transactional. Hey, we need this from this team. We need this integration. We need this kind of experience. So what that ultimately ends up being is causing that friction between these different teams and ultimately diluting that developer experience, making it a place where actually, we don't enjoy necessarily working as much. And because of that, it means that there's productivity gains that we're losing. It means that we're not able to collaborate as effectively as we potentially could be. And actually, there's an opportunity for us to be able to collaborate more effectively. Because when you think about the open source community, they do this day to day. They do this globally, they do this asynchronously, and they do this in a way that they're able to lower the barrier of entry so that anyone is able to collaborate. I just take a look at the project, I then go and contribute into that based on what I can actually bring to that project. So ultimately, there's actually things that we can learn from the open source community that we can bring to our internal day-to-day development within our own organizations, within our own businesses. we can adopt those open source best practices internally. And that is what is known as inner source. It's the idea of bringing those practices of working asynchronously, defaulting to open. Because if you think about it, probably inside your organization, I would bet right now today that you have a repository, you have a project, for example, that you're working on that is locked down to your team. Maybe there are a couple of other folks that have access, but it's not available to the entire organization. So being able to default to open, and I'm not saying open your internal repositories so that the whole world can see. What I mean is anyone inside your organization is able to view that, is able to collaborate. And what that means is you can get into this world where rather than needing to raise tickets or have a team meeting or have interdepartmental team meetings and things like that, instead, you embrace the way that open source communities work. And what do? They raise a pull request. They create a branch. They look at the documentation and the requirements and the expectations for a given project. And they raise a pull request. Certain checks are made using automation and CI/CD practices. And then those teams collaborate asynchronously using pull requests. And that is the beauty of this approach, is you then are able to start building this community which is able to collaborate with each other in a way where there's less friction. So we're embracing those open source principles and practices. Now, all of that actually comes at a time where security is more important than ever. And the interesting thing, when you look at lots of the research that is out there from many of the different companies that research in this space, we're still just as likely these days to find vulnerabilities. And what I mean by that is if you look at code that we wrote 10 years ago and code that we wrote maybe last week or today, the percentage of vulnerabilities that we're finding in our code is going up at the same rate of the number of lines of code we're writing. So even though we're all more aware of the vulnerabilities that are potentially going to be brought into our applications and the importance of security, we're still seeing those being introduced. We're still seeing all of that be a problem from an application security perspective. So actually, there's a way that we can bring security into the lifecycle, because we believe security is not an afterthought. It's something you should think about as part of your development lifecycle. So we'll explore that in this session here as well today. So let's kick off maybe in a natural place and a kind of a home feeling, I suppose, for a lot of folks who will be tuning in here. When you think about GitHub, you probably initially think about repositories. And that is absolutely where GitHub started, with Git repositories. But there is so much more that I want to talk to you about here today, and the wider development lifecycle that you can embark upon and take a look at here. So we'll take a look at GitHub repositories in a demo in a moment and see how we can actually use that experience to bring this collaboration, to open our repositories internally within our organization. But the other thing that I want to talk about here is GitHub Codespaces. And this is the time where I'd love maybe some audience participation. So if you're listening in, feel free to type in the chat here. Have you ever had one of those scenarios where you've said the words, "It works on my machine"? Or have you ever joined a team or joined an organization where maybe you've had to go and follow some kind of setup experience? You've got to install your IDE, you've got to install a load of dependencies, a load of frameworks, whatever language dependencies you need, etc. And that can take hours. In some cases, that can take days as well. I've heard from many organizations that I've worked with. And it's a very frictionful experience. It blocks you from being productive. And let's face it, as individual developers, it's really frustrating because I just want to get stuck in. I want to get making something and building something. And as an engineering lead, you've got people on your team that if they need to rebuild their machine, you've got a new joiner, you know you've got to block off several days until they can start contributing. And no one's happy with that experience, but there's a better way. And that is with GitHub Codespaces here, which I'll talk about now, which is this on-demand development environment that you can use with GitHub. So with that, That's probably enough context. Let's actually go and jump into a demo here. So you can see here, I've got a repository here. It's actually private. And one of the things you can do with your repositories with GitHub Enterprise is you can change the visibility. So you can change the repository visibility to either be public or to be internal. And public literally means, publicly available to the world, just like any other open source repository. Whereas internal means any organization that is part of our broader enterprise account from a GitHub perspective, anyone who is part of that enterprise account and has a user associated, they can go and view and have access to that repository. Now, of course, you still control permissions on a repository by repository basis, but it gives that visibility into what's happening within that repository. So it starts getting rid of those silos, and it allows us to bring that open source mindset to our internal organization. Now, if we just take a look at this repository a sec here, it looks like any other GitHub repository, right? You've got your files here, I've got my issues, my pull requests, and other bits and pieces. But if I scroll down, one of those super critical parts about open source, about inner source as well, is having good documentation. And I know I say this, I'm probably getting some eye rolls maybe as people listening in, or a sigh here, but documentation is so important. Take, for example, the README file. The README file is probably one of the most important files in a Git repository because it's my shop window. It's the way that I can see into that project and understand what it is, who owns it, what it means from a business perspective. So is it like the core business critical application? Maybe there's a link to a demo or a screenshot or something similar. This is what gives me that ability to be able to understand, as someone new to the project, someone not on the host team, let's say, who can contribute in easily. So remember what I said a bit earlier, that inner source is all about making it as easy as possible for others to be able to contribute into our project. And this is one of the ways that we can do that, by making a very clear README. Who owns that particular project? What are the steps that you need to go and do to actually build and deploy and execute on that? What are the expectations in terms of contributions? What are the standards that you're expecting to see as well? So you can see all of that is documented here in this README file, including like a flow diagram from a deployment perspective as well. So that's all good. This is following those kind of open source practices, good documentation there, etc. We can see that we've got an issue and some pull requests open, so we'll take a look at those in a sec. But the next thing we'll take a look at is Codespaces. So a bit earlier, we mentioned with Codespaces that it's your on-demand development environment. It gets rid of the problem that works on my machine. So many of us will be familiar with going into GitHub, clicking that green code button, hitting this kind of copy icon here so we can get the URL, cloning the repo to our local machine, and off we go. We start developing. But actually, there is a better way that we can go and do this. And this is using GitHub Codespaces. So if I just click this button here to create a new code space and explain what's going on here. So GitHub Codespaces is your on-demand development environment. And what you're able to do is you're able to define what you want that development environment to look like declaratively. So as code, a bit like we would infrastructure as code, pipelines as code, configuration as code, we define what we want our development environment to go and look like. So you can see here what's happening is some kind of image has been found. It's building some kind of container for us there, so a Docker container there, and it's now going and pulling all of the layers for us. If we actually see what's going on in the repository here behind the scenes, you'll see that I have this folder called a .dev container folder. And this is the convention that you can use to, let's say, define declaratively what you want that development environment to go and look like. So you can see I've got two different files here. I've got this dev container JSON file. I've got this Docker compose YAML file here as well. So let's take a look at the dev container JSON. You'll see that we've got a number of different properties and configuration in here. So we're specifying what the underlying image is used. So, the binaries, the frameworks, ultimately which are packaged up using a Docker image, what we're referencing that, where's that actually coming from? What kind of ports that we want to have open, extensions that we want to have available in our editor as well, some native settings, etc., and then a post create command and what requirements we have for the underlying compute as well. So overall, it's really defining that environment in a declarative way. And you'll see again the Docker compose YAML file, again specifying some kind of image on the GitHub container registry that we're using there as well. You could use a Docker file, you could use different components there as well, but this just happens to be how we've done it for this particular project here. And in the time it took me to explain GitHub Codespaces, what it is, etc., you can see we've already got our environment created. Now you can see it looks a lot like Visual Studio Code. If I just zoom in here a little bit, just to make sure we can see that on screen, there we go. So you can see it looks a lot like Visual Studio Code, but I just want to point out to you, I am in my web browser. That is an address bar, so I could be productive on my iPad, on my phone, on my Surface, wherever I'm working. If I'm maybe going home from the office, I'm on the bus and something urgent comes up and I need to take a look, guess what? I can log on, tether from my phone for the internet connection, get connected to GitHub Codespaces and start being productive. I don't need to get things installed on my machine anymore. I don't need to have all of those dependencies and frameworks anymore and fight that battle in terms of getting my development environment set up. I'm now able to be productive very quickly and easily. So you can see that I've actually got a terminal. I can go and list what's in my folders. I can go print my working directory, etc. I can, of course, go and start editing things as well. So I can take a look at the source and start updating whichever files I want to go and update here as well. So let's actually make this real. Let's actually go and make some changes to the application. So in demos, I don't trust myself to go and type things out, so I've got some tricks ready here. I'm just going to use the Visual Studio Code tasks here. I'm going to go and run a task. And what we're going to do is we're going to code a feature. And we're going to code a book star rating feature here. So I'm going to create a new branch. And there we go. You could see what's happened behind the scenes is a number of files have been created, and we've switched the branch that we're working on. So if I take a look on the left-hand side, you can see we've got a number of file changes here that I now need to go and commit to my GitHub repository. But before I actually commit those, I want to do some kind of local testing because I don't want to just push anything up to my GitHub repository to a branch. I want to make sure I've done my due diligence, I've built it, I've tested it, I've done some kind of local work before I've gone and pushed that up. So again, what we can do here is I'm just going to run another task just to make it a bit easier for myself. And we're going to go and run a Docker build because remember, the application we're building here is a Docker container. That's how we're publishing that application to Azure. So the bookstore that we're running here runs in an Azure web app container, and the way we publish it is using a Docker container image. So for our local development, let's just go and build the Docker image locally. So you can see we're first running a Maven compile, we're running a series of tests, and then what we're doing is we're saying, okay, now we want to go and build the image. So we'll build the image with this label. And you can see now, if I just expand this here and zoom in, this is that same experience that you're used to when you're building your Docker images. It's running through the different steps that we would see in a Docker file. And I haven't had to install anything on my machine. You can see I'm still in the browser here. So that's just completed there. Now we've got our image. Awesome. So if I just zoom out ever so slightly and just bring this down a bit here, there we go. What we're going to do is we're going to run that application because, again, I've built it. I know it compiles. I know that we got a successful Docker image as a result. Let me go and run that. So let's go run that container now on port 8080. And you can see again that it's just running in our local terminal here. And I say local, I'm going to call this cloud local because it's not running on my machine. It's running on a code space somewhere in GitHub. And you can see I've got this green button to open in browser. So we can go connect to the forwarded port. There's some authentication that happens. And there's my app. There's the bookstore that we saw a screenshot of in the README a little bit earlier. Now, the beauty of this is I can go and change the visibility of that port. So right now, only I can access that. And that's what happened with the authentication experience that you saw at the very beginning. I could go and change that port visibility to be public. And if I go and refresh, notice that we didn't have that authentication dance. So if I'm working with a customer, and let's say I'm collaborating, want to show them an iteration of the application, we don't need to be together. I can send them that link. They can go take a look at it, click around in the demo, and ultimately then we can collaborate separately there virtually. So, that's always a nice thing to go and show off here with Codespaces. Again, you can also go and take a look at extensions here as well. And all of my extensions that I prefer are installed because what I can do with Codespaces is use the Visual Studio Code login with GitHub and get my settings synchronized across the various environments I'm working in as well. But you'll see many of these extensions which are installed right now are actually the ones that were defined in that dev container JSON file a little bit earlier. Now, you're not just limited to the browser. You can, of course, use native Visual Studio Code. You could come in to VS Code here, connect to a code space, and you can see I've got a couple open here. I could go and open that, and there we go. I've got my native VS Code client opening the code space, which is hosted on GitHub. So again, the dependencies, the frameworks, the compute is not running on my local machine, but I'm using my local VS Code clients to connect to that code space. And you're not just limited to VS Code either. So what you can also do, if I just click over here, is you can also use the JetBrains gateway. So if you're using things like JetBrains IntelliJ or some of those other suite of IDs from JetBrains, you can use those. If you're a data scientist or into machine learning and you want to go and use Jupyter Lab, again, you can use Jupyter Lab as well. So those are a couple of aspects that we announced back at GitHub Universe over the last month. And finally, on Codespaces, if you're an individual developer, so you're not part of an enterprise or teams, for example, you can get a free allowance of GitHub Codespaces already as well. So that's something you can get access to. So you can get started with Codespaces for your own project. And of course, you can use this in teams and enterprises as well. But that is something then you would be kind of paying per minute, per use, etc. So any questions on that, feel free to get in touch. Now, let's just go ahead and finish pushing those changes here. So we're going to go and commit the Bookstar rating implementation to our branch on GitHub. There's no branch in place yet, so yeah, we want to go and publish that branch. There we go. And of course, we want to go and create a pull request because we've created and committed those changes on a separate branch. Now we want to merge them into our production code base. So let's just make that very simple there. Normally, if I was making a pull request, I'd provide some more details, but want to make sure we give enough time for some of the other aspects here. So you can see that we can see our pull request right within Codespaces. I can click the link and get taken back right to the GitHub repository where my pull request is. And as I scroll down in my pull request, you can see that actually there's a number of checks that have automatically happened. And this, again, is one of those real core practices that you want to bring in if you're trying to adopt an inner source way of working, or even for open source as well. Because what we're talking about here is continuous integration and continuous deployment. So automation, thinking of those really strong DevOps practices that we're well aware of in the industry. The thing about using these automated practices is that we're able to make sure that anyone can easily come in and contribute to the project. And if they've broken the build, if they've maybe changed something that breaks a test, for example, guess what? They're going to know. They're going to know because it's part of that pull request flow. It's part of that barrier of entry to committing code to our production code base. So it becomes a check, a quality gate that people then have to go and work through. So if I just scroll back up here, what's actually happening behind the scenes is GitHub Actions are being executed. And you can think about GitHub Actions as the approach natively to use CI/CD techniques inside of GitHub. And we call them GitHub Action workflows. And that's effectively our pipeline of work, the repeatable set of tasks that we want to go and execute. How are they defined? Well, if you take a look in your repository, you'll see there's the .github folder here. And below the .github folder, we have a convention for a folder called workflows. And you can see we've got a number of different YAML files. So if we just go and take a look, let's say at this build test publish YAML file. Clue is in the name. This workflow is going to build our code, test it, and ultimately publish it. So let's take a look at what's going on. As we zoom in, we can see we've got some kind of name property going on here, and then there's some kind of trigger. So the trigger is really what event-driven scenario causes that workflow to be executed. So is it on a push to a branch? Is it on a pull request being created or closed or synchronized? Is it on a GitHub issue being created? Is it on a comment being updated in a GitHub issue? And this is the beauty of GitHub Actions, is you're not just limited to CI/CD event triggers. You can also build upon other GitHub events as well. So project board being created, a roadmap or milestone being added, for example, number of different items you can go ahead and trigger based upon those. And this is actually something we use a lot internally in GitHub. So my team, for example, do a lot of events. We have a repository open to the company. And if someone wants us to go and speak an event, they create an issue. Some automation kicks off as a result using GitHub Actions. And then we're able to go and triage that and update that using labels, etc. So it helps you in terms of you using your processes internally as well, not just CI/CD. So you can see here that we've got this push trigger. So when we push to a branch, this is actually going to go and fire off here. Now, we've got jobs, and within a GitHub Action workflow, you have a series of jobs, a series of discrete pieces of work that are going to happen. And we have this first one called build parameters, and this is just a name we've given to this particular job. It's going to run on an Ubuntu image here, and this is what we call a hosted runner that actually goes and runs using GitHub infrastructure. Available is Ubuntu, macOS, and Windows as well, hosted by GitHub, but you can also self-host your agents or your runners as well if you prefer. And as I scroll down a bit here, you'll see that we can define a series of steps. Now, I'm going to draw your attention to line 25 here. I'm curious if anyone in the chat can tell me what is interesting about this convention here, and specifically this aspect here. So we've got actions/checkout at v3. So we've got some kind of naming convention happening there. Now, actually what is happening here is this is referring just to another GitHub repository. So if I go to github.com /actions/checkout, it's just another GitHub repository. If I take a look at the releases, you'll see that there are several releases that have been tagged with a version number. So v2.6.0, v3.2.0. So I can go and take a look at, what are the changes between v3.2 and v3? Well, actually, it looks like they're tagged as the same there. So when we use this uses property here, if we just jump back to the code, it was over here, there we go. What we're saying is, GitHub, go and use that action that is available using the app v3 version, the v3 version of that. So that's quite powerful because actually we're open source maintainers running their projects, they're running them on GitHub, and we've got this thriving community that is actually publishing GitHub Actions to the marketplace. So if we go to the top of the GitHub site there, click on Actions, you can see that we've got over 16,000 actions which are being published. Some of them by verified creators like GitHub, Azure, ServiceNow, and others. Some of them by people in the community. As an example, you can see I've made my own action to pass an RSS feed, for example. So, you have a lot of power available to you because you can build on top of the actions that have been published by the community. Now, as an enterprise, of course, you can restrict what actions you want to go and use and maybe only use ones published internally. And that's a decision you can make and you can go and configure. You can also, of course, run scripts natively inside of your agents there as well, or your runners. And I'm just going to scroll down a little bit further because there's another example that I want to show here. And here we go on line 138. So I'm curious if anyone is able to go and, there we go, and determine what is actually happening on this line. So it looks kind of similar to what we saw a moment ago. It looks like it's referencing some kind of GitHub repository, but it's doing a little bit more. It's going into the GitHub folder, workflows, and referencing some other YAML file. Now, if you think about the scenario of inner source that we mentioned a bit earlier, and being able to build upon each other's work, be more collaborative internally, this is actually a really great example of how GitHub Actions can help you with that. So if I just go to this repository here and show you what's going on, you can see this is just another repository, which is available internally to users within this Octodemo organization. And if I just go and jump into these YAML files, you can see this is exactly the YAML file we were referencing. So what we've actually got here is something called a reusable workflow. So think about that concept of being able to have that workflow we define once, but we're able to reuse it across our business. So let's say we have a standard pattern for building a Java application, testing it, compiling it into a Docker image, for example, and then publishing it to, Azure Web App for Containers, for example. That's exactly what that YAML file is doing. And instead, what we're doing is we're defining a set of parameters or a set of input properties that could be changed to make it work across the different projects in the organization. So what that means is we're not redefining the wheel and recreating the wheel several times over, but instead we can define it once, reuse that workflow across multiple teams in the organization, and be more effective and be more collaborative and work for the greater good rather than teams in separate silos there. Now, you're probably thinking, okay, Chris, this sounds great. Understand this from the inner source perspective, but you mentioned some aspects about security as well, and we haven't really talked about security yet. But actually, security has already been part of this demo and part of this presentation here, and I want to show you how. So you can see that we've created a couple of pull requests. There's the one that I created during this demo here, and there's actually one that I created just before we went live a little earlier on today. And as we scroll through the pull request here, we'll see there's a number of checks that have been all green and look good, but actually there's one that has failed there. Now, that's kind of interesting. Why is that failing? Because obviously we can't merge that into our production code base yet. So if we take a look at the details here, what we'll see is that actually, as part of that pull request, we've done some security scanning. And what you can see on screen here is code scanning capabilities in GitHub. And GitHub's code scanning capabilities come in two forms. The native built-in experience is called CodeQL. And the idea behind CodeQL is you can take your code, convert it into a database, and query over certain code paths. So what you'll see with this example here is we've gone ahead, identified that actually we're taking in some kind of input, but all the way through that call path, from getting that parameter, passing it into the search books method, going all the way through here through our call stack, but not once do we sanitize that input. So you can see, as an example, that this is an example of a potential SQL injection attack. And because we had that as part of our pull request, because we had that as a quality check, that is something that we have prevented getting into our production code base. So you can see that CodeQL is one of the scenarios that I mentioned there. If we jump to our security tab there and look at code scanning, you'll see that we can also add additional scanning tools as well. So if you're using a third-party tool that supports the Serif output format, then you'll be able to integrate that into the code scanning and code alert capabilities of GitHub as well. And you can see there's a number of different examples here that help you configure GitHub action workflows to use those third-party different tools there as well. So just to call that out, and you can see all of these alerts, for example, are coming from Gripe. Gripe is an open source container scanning tool from Anchor. And this is not one which has been executed using CodeQL, but was executed in our GitHub action workflow using that third-party tool. You can see that I'm getting all these alerts right from within GitHub. I'm not having to go to another security tool or to another window or to another tool elsewhere. I get this right where I'm coding. So from that developer experience perspective, I'm not having to context switch. I'm right in my repository, where my project lives, where my issues are, where my pull requests are, and able to carry on being productive here. So we talked about CodeQL and code scanning and the potential third-party tools you can integrate as well with code scanning. Code scanning is great for the code that we write, or maybe that the third-party tools can scan for. But in the world we live in today, we use open source way more than we used to many years ago. We're not going ahead anymore and creating our own login provider. We're not going and writing our own identity store anymore. We're using the SDKs, we're using the packages and the frameworks that people have published, whether it's companies like Microsoft and using NuGet packages in .NET, for example, or whether it's our favorite NPM package from a community maintainer. We rely on open source to build our software. So we need to be sure that the dependencies we bring in to our projects as well are sound, and that we're not introducing vulnerabilities that way either. That is where Dependabot comes in. And Dependabot is free for you to go and use on public repositories. You can use it on GitHub Enterprise and private repositories there as well. But code scanning that we talked about a moment ago is available for public repositories, or you need to have GitHub Enterprise and GitHub Advanced Security. So just bear that in mind. But Dependabot has two different capabilities. It can help you identify security issues. So thinking about an issue where there's a known vulnerability in an open source package, or it can help you in terms of keeping versions up to date. So not necessarily a security vulnerability, but just helping you stay on the latest and greatest versions of frameworks and packages. So you can see there's 7 different examples that have been highlighted here that have some issues with the dependencies we're using. I can click on that alert, and again, right within my repository, haven't had to go to another tool elsewhere. I can see that there's some kind of package that we're relying upon. There's affected versions here. I can see which version has been patched, and I can understand what potential workarounds there are there. I can also determine other sources that have referenced that and look into that in more detail if I need to. And I even get the heads up view in terms of the severity of that. So what is the attack vector, the complexity, etc. So I've got everything I need at my fingertips to be able to go and take action on that. Now, if I jump back over to my pull requests, you'll see that we have a number of pull requests that have been automatically created for us as well. And these were created by Dependabot. So these are the examples of, let's say, the scenarios where there's not a security issue, but Dependabot has detected, for example, we're using something in Terraform, I believe here, by the looks of it. And if we just go and look at the files changed, you can see that it's detected there's a newer version of a provider available that we can go and use. So there's not necessarily a security issue, but if we want to keep up to date on the latest and greatest dependencies, Dependabot has helped us out by raising a pull request and detected that. Better yet, because it's a pull request, all of our checks have taken place. So I can see the builds are still working as expected. I can see there's no security issues that have been introduced here as well. I can see there's no dependencies that have been introduced with vulnerabilities here as well. And that's what dependency review does. That is a capability of GitHub Actions to help you prevent new dependency issues going into your production code base. And then finally, the third part of the kind of security puzzle, if you like, is secret scanning. Now, love to see in chat. I always get some giggles at this point when I do this type of talk. Who's ever committed a secret into code? Better yet, who's ever done that with a production secret? I know I have. It's not fun. It's not something that you want to do because then you have to start rotating secrets, making sure that you've kind of burned that secret from existence and that it's not being used to access any production databases or endpoints, etc. anymore. It's something that happens. We're human. We make mistakes. And this is where secret scanning can go and help us. So secret scanning has a couple of options. There's a number of partners that GitHub partners with to go and alert based upon those issues. So you can see there's a Google API key, for example, in our code base. And we can see here that's in the book service test Java file. Maybe it's not actually a real issue here. So we could go and dismiss that as a false positive. Maybe it's used in tests. Or you know what? Maybe it's actually already been revoked. So we've taken action and all is good there. Now there's a number of providers that GitHub works with. And if one of those providers is not available, let's say like SSH keys, for example, you can come in to your settings in your repository or at the organization level, go to code security and analysis, and you can even define your own custom patterns there as well, based on regular expressions. And the idea there is the team don't want to create a load of false positives for you to go and investigate. So you're in control. You can define those custom patterns there. Again, if you want to use secret scanning, that in a private repository, you need GitHub Enterprise and GitHub Advanced Security, but that is freely available for open source repositories as well. And finally, something we won't have time to cover, so we'll make sure we have some Q&A, but you can even do push protection as well. So rather than waiting for the secrets to be in the code base, something that you can do is have on a push to your repository that there's kind of a scan, there's a check against those partner patterns that we just mentioned. And if one of those partner patterns is present in the code, guess what? You're going to be blocked from pushing that to GitHub. And then there's a URL that you can use to override and say, actually, this is good. This is just a test, for example. Or actually, what, block this because this is not, this is actually a real secret. So please don't let this go into production. So with that, let's jump back to the slides and just wrap ourselves up here. So we've covered actions and security and secret scanning. Ultimately, what we've taken a look at is how developer experience overall is part of that experience. As a developer, we want to make sure you can stay in your flow, you can be productive, and ultimately you can enjoy your craft and enjoy as you're doing your engineering work. So with that, folks, in terms of how you progress and what's next, try out GitHub Codespaces. I mentioned a bit earlier, if you're an individual, you can go ahead and use some of that free allowance to go and spin up your on-demand development environments. Go and start using GitHub Actions to go and get those quality checks built into what you're doing and secure all the things. Security shouldn't be an afterthought. It should absolutely be something which is a core part of the applications that you build. So with that, that's me. Time for some Q&A.
Brilliant. Thank you, Chris. Apologies about the technical issues at the start, but hopefully I'm coming through okay now. Thanks for doing that session. We had a few questions come up in the chat and a good bit of discussion towards the end. So Fuel Snable's actually been using Dependabot recently, and for about 100 plus repos. And he was wondering, and maybe you might be able to touch on perhaps a little bit of the future of Dependabot and how this looks like. But in terms of being able to view your notifications across many repos rather than just one by one, is that something that's in place at the moment, or is that?
It is, yeah, absolutely. So there's a couple of things that have changed over recent months. So we have something called a security overview tab, which is available in an organization in GitHub. So that's actually been changed from being for GitHub Advanced Security users only to anyone using GitHub Enterprise. So if you're using GitHub Enterprise, you have the capability, you're able to go and use that today. And then at GitHub Universe, we actually announced an evolution to that overview page as well. There's two different views. One is like a security risk overview page. The other is like a security, I forget the exact term, but two different dashboards. One to help you understand where is Dependabot enabled, where is security scanning enabled, where is code scanning enabled. So where are kind of the gaps in our armor, if that makes sense. And then there's a risk view, which is we've got them enabled on these repositories, but these are how many alerts that we've got open from a high, medium, kind of critical vulnerability level as well. So absolutely something that's available there today for you to go and take a look at.
Okay. We've had one just coming from Ammon around, does Coursera virtual environment like Codespaces? So any thoughts on that?
I'm not sure about Coursera virtual environment. I'm not sure what that is, to be honest.
We can search that online and get back to you, Ammon. If you want to reach out to us separately at lunchbytes@microsoft.com, then do follow up with that and we'll try and get back to you on that one. In terms of Codespaces then, Chris, you showed a real cool demo, and I remember when we've worked with Codespaces in the past as well, and recently we had GitHub Universe, a large conference, talking about all things GitHub, what's coming up. I guess I wanted your take on what are you most excited about with Codespaces coming down the line?
I think when you look at where things are going, like with the previews that have been announced, Jupyter Labs, looking at things like the JetBrains suite as well, getting that ability to use it with whichever tool you prefer to use, I think is great. I think you've also got things like GPU support is actually in private preview as well right now. So you can see that, I guess, what we think as a developer, that scope is evolving because data scientists, machine learning, etc., ML ops are all forms of development in their own way. And they need that kind of specialized hardware, that specialized kind of compute as well. So you're really seeing that investment happening in that space. I think the other thing as well, which of course is awesome, but we haven't got the time to cover it in detail today, is also Copilot. When you think about InnerSource, there's potentially different repositories that we're using across our organization, and each of those repositories might have different languages, different frameworks that we're using. And Copilot can be that awesome pair programmer for us, using AI to actually go and help us be more productive, more efficient. And there were some great talks actually at GitHub Universal around that. One around like a backstage pass to Copilot, understanding how it works, etc., and what's going on. So I definitely encourage folks to go and take a look at that as well, if that's of some interest.
Brilliant. And one more thing from me. So I know there's available, for example, you've got GitHub Actions exams that you can go take. You can do advanced security exams and administrator exams. In terms of people learning more about this and down the future, if they wanted to maybe get certified and things like that, we can direct people to those sites to take those exams. But are there any really good sort of learning materials or sites that you want to share with the audience that they can go and take a look at?
Yeah, sure. I think there's a couple I would call out. Obviously, Microsoft Learn being one. I think there's some great content up there. The other is GitHub Skills, so skills.github.com. There's a number of hands-on courses. I don't know if they're really courses. They're like modules in a way. But what they actually do is they use GitHub Actions to guide you through an experience. So it's all very hands-on. It's not theoretical. You actually got a GitHub repository that you're using to go and learn some of those concepts. So skills.github.com, take a look at that, because that'll give you that hands-on experience of learning as well.
Brilliant. Thank you so much, Chris. Thank you for doing that session, and thanks everyone for joining and asking the questions during that. Steph, I wanted to hand over to you, I think, now, so we can sort of wrap up today's LunchBytes.
Awesome, thank you. So just a note, as we talk about that hands-on learning experience, what are those next steps and the different skilling things that you can do? If you'd love to have a Cloud Skills Challenge, which is a gamified hands-on learning experience, like run for your team of developers, please reach out to us. Or if you'd like to participate in an open hack, definitely reach out to your account team and they can get that set up for you. Anything else, like Tag said earlier, email us at lunchbytes@microsoft.com. Next up is, you can also check out our very new this year, the developer website hub. So this is everything developer for the UK, lots of customer stories, experiences, and resources on that site. You can reach that aka.ms/UK developer. And on there is also our community callouts. So if you're looking for a community near you or a hybrid one that you'd like to touch base with in the UK, we now have a community callouts page within the aka.ms/UK developer, the website that we have set up for you. And you can find one that is local to you or hybrid. And then finally, you can check out this pre-recorded on-demand episode as well as many more resources on our YouTube page at aka.ms/lunchbytes. Finally, just ending on, we right now have the festive tech calendar going on right now. It's a really exciting show that we're doing with the Cloud family community within the UK. And what we'll do is we'll run a little video to close out the show. Thank you everyone so much. We'll see you in the new year for season 2 of LunchBytes. Thank you, Chris, for joining. Bye, team.
Thanks, everyone.